an assistant professor over in the Nelson Institute, starting this semester, right? So still somewhat new to UW, I guess we could say. Joel is part of the RAISE initiative that the university is pushing forward now. Before coming to UW, Joel was a postdoc at Stanford in the global policy lab there, and then prior to that did his, at least his PhD. I don't know if he did other degrees before that, but at UC Berkeley. So very happy to have Joel here. Joel's gonna, I won't read the title, but Joel's gonna present some of his work, although it's important to note, I don't know if you'll get into it at all, that he certainly has expertise in other areas as well. A lot of his work is really connecting agriculture and environment, using a variety of techniques, remote sensing, machine learning, lots of these types of things. Again, some might come out in here, but I'm sure there are lots of other pieces that won't. And some of this work is domestic, some of this work is applied internationally. So very exciting, very happy to have you here, and with that I'll turn it over to you, Joel.
Awesome, thank you. Yeah, so like Paul said, I mainly work on climate change adaptation in agriculture. I have kind of a methodological focus, and so I do a lot of remote sensing, machine learning, causal inference stuff, and then I usually work with collaborators who have some kind of like topical to study whatever's going on to adapt to climate change in agriculture in that place. But this is something quite different from that. One of my advisors during the PhD, Ted Miguel, invited me to work with him and Marshall and Saul, updating a meta-analysis on the impacts of weather shocks on different forms of violence. And that kind of started me working or collaborating with all three. Saul was my postdoc advisor on stuff related to climate change and conflict. And so this is kind of the current culmination of that line of work, investigating how climate change and conflict could increase the risk of economic collapse in Africa. So just for kind of a preface, this is a figure from that revisiting of the meta-analysis that became a handbook chapter. So part of the reason why Ted invited me to work on kind of a redux of the meta-analysis is because this literature on the relationship between climate and various forms of violence has grown rapidly. They did their first meta-analysis in 2013, and based on kind of a keyword search, that literature had doubled by the time we were starting to look at doing this other meta-analysis. And here's kind of what came out of that, just to, again, give some background on this literature. There is really strong evidence of a causal link between temperature or weather shocks more generally and various forms of violence. So this is our meta-analysis figure for group conflict. Sorry, it's not very wide, but this is something 50 or so studies analyzing various forms of group conflict, different kinds of weather variables, though most of them are temperature, and you see that most things are to the right of that zero line. So pretty robust finding across different settings, and then within that same meta-analysis we look at other kinds of violence like interpersonal conflict or even like self-harm and find similar things. So it's a pretty general and robust finding. We then did a piece, so maybe let me take a step back. It's like this kind of said that there was a lot of work showing some sort of causal relationship between weather and various forms of violence. But what we know a lot less about is how do we get rid of those impacts? There's surely things that we can do to weaken that response. And so one thing that we looked at in a separate paper was just how income or wealth moderates that response between temperature shocks and civil conflict in Africa. And so here we were making use of a really nice data set that Marshall's group had put together, where they had really disaggregated wealth data, something like the maybe, let's say, 10-kilometer resolution. And so we could see, did local wealth matter for moderating this relationship? Did national wealth matter? And what we found was that national income per capita mattered a lot more for moderating this relationship than local wealth, which is pretty interesting, I think. A lot of the economic theories around why these kinds of shocks might induce conflict would kind of point towards this being the local income being the thing that matters more. This says that maybe it's something more like institutions, state capacity that is leads to better adaptation and a weaker response to those extreme temperatures. One more kind of like piece of background that I wasn't involved in. Some years ago, Ted Marshall-Saul looked at the relationship between warming and just GDP growth. And what they found is that there's this kind of U-shaped relationship where economic growth slows when you have kind of lower than optimal or higher than optimal temperatures. So this is something that we're going to, it makes us think that potentially there's some kind of interaction between these forces going on. So, our previous paper showed that poorer countries are more likely to suffer a conflict due to warming. And then their previous paper shows that warming slows growth. There's also some evidence, though it's kind of old at this point and kind of doesn't use the latest methodology, but there is some evidence, and intuitively it should totally make sense to us, that conflict slows growth. And so that kind of leads us to think that it might be possible for countries to get caught in a kind of climate conflict poverty trap, where warming slows growth and makes conflict more likely, and because of that, a country might stay poorer longer and become more susceptible to these increasing temperatures. Kind of one thing that I wanted to point out for this talk in particular is that Reed Bryson, the founder of the Center for Climatic Research, did some work kind of in this vein, looking at civilization collapse due to big changes in climate, and kind of forecasting, or maybe not forecasting, but saying something about what might go wrong if we don't do something new to adapt. So I thought that that was kind of a fun link to make here. And then just in terms of looking at kind of correlations in the data, we think that we see some evidence that countries might already be making this kind of a transition. So our data set is going to span from 1960 to 2023. Here we just split it up into three kind of roughly equal sized periods. And there's always been kind of a collection of countries or country years, some sort of relationship between having really persistent conflict and relatively low income. What we see in more recent years is that countries maybe like Mali have come to kind of fill this gap between this low conflict and various levels of income or growth part of the space into kind of this middle region where there's more intermediate levels of conflict and kind of stagnating growth in the case of Mali. So that's just a correlation that we see in the data, but it kind of motivates a little bit what we're going to be looking at. So theoretically, we're going to try and say something about why might climate change induce poverty trap or similar kind of persistent economic decline. And then empirically, we're going to estimate some statistical relationships using kind of the best causal inference methodologies available to us with these data to say something about how strong the relevant relationships are between warming, conflict, and growth. And then to try and say something about, I want to be very careful here. We're not going to try and predict the future because we can't know how global or regional macroeconomic conditions will change or what kinds of new technologies might be invented and adopted. What we'll do is we will try and project the effects of warming given the empirical relationships that we've seen so far. And say, so one way to interpret that is, here's what might happen if we leave things as they are. We don't have any sort of intervention to deal with this warming, to adapt. And then we're focusing on Africa in particular because the way that we think that this poverty trap might arise, countries would be particularly susceptible if they're lower income and if they're hotter, and so there's kind of a larger collection of countries in Africa that have those conditions, and so ex ante we might think that it's more plausible that we will find this kind of equilibrium that we're positing. So let me just check how far I am. The theory. So this is going to be kind of just a graphical model of why this kind of trap might arise. The first piece of this is going to be, we have this curve that shows how income growth changes in the level of conflict risk. And we've modeled it here as just a linear function. So in terms of empirically, is there anything to support that? We'll find that, I'll show the result later, but basically we'll find that the effect of conflict incidence on growth is a one-time decline in growth rates, and so it seems to align decently well with this assumption. The other piece is going to be a curve that relates conflict risk to growth. So here, conflict risk is going to be bounded between 0 and 1. So as long as you think that faster growth reduces conflict risk, there is some empirical evidence that was, one of Ted's early papers was looking at the relationship between economic growth and conflict risk in Africa. So we think that this is a kind of plausible relationship. And then we're just going to rotate this and put them together, and you get a graph that looks like this. And so equilibria in this very simple kind of graphical model are just places where these two curves intersect. This middle equilibrium is unstable because if you get perturbed from it, you'll either get pushed towards the upper high growth, low conflict equilibrium or the lower high high conflict, low growth equilibrium. But those other two equilibria are stable in the sense that if you get small perturbations, shocks that to conflict or growth, we would expect that you kind of revert back to those equilibria. What does warming do in this model? So Ted, Marshall, and Saul's earlier work shows that for the vast majority of countries in Africa, at least, warming slows growth, but that doesn't necessarily interact with conflict risk, and so we're just shifting the level of the growth curve down. And then warming elevates conflict risk, kind of different, and what we showed in our other paper is that it elevates conflict risk kind of differentially depending on the level of income. That's not exactly represented here, but you can kind of see, because conflict risk is bounded at F1, it shifts more for lower conflict risk places than higher conflict risk places. And so putting this together, it's kind of hard to see this compared to, I guess you have to go back to here, but these equilibria kind of shift down along, or I guess down and to the right a little bit. So with a moderate level of warming, you would expect slower growth and maybe slightly more conflict risk if you're at the high equilibrium. And then, if you have a really big perturbation, you might actually get pushed into the lower equilibrium. And then really extreme warming eliminates the high equilibrium. If you push that conflict risk curve far enough to the right, then all that's left is the lower equilibrium. So this is just a theoretical model that explains why we might see changes in conflict risk, growth, and kind of the persistence of those underwarming. Turning to the data, we're going to estimate three key relationships. They don't directly map to the model, but they'll be the key relationships that we need to conduct our simulations to see, to say something about what might happen under climate change, barring intervention. So, like I said earlier, this is going to be 1960 to 2023. We're going to estimate the effect of civil conflict incidents on economic growth. This is one that is kind of interesting. It has been estimated a number of times before, but there's relatively little modern causal inference looking at this question, so it's kind of fun to be doing that kind of on our own. But the other two are building on our previous work. So the effect of temperature on civil conflict incidents is going to be based on the paper that I worked on, where we looked at local versus country level wealth. And then the effect of temperature on growth is going to be based on Ted, Marshall, and Saul's previous work on that exact question. There's one other relationship that we're going to estimate as part of the effect of temperature on civil conflict incidents, which is going to be the persistence of conflict. There's a lot of research in political science suggesting that conflict is persistent, and we're going to try and get at that a little bit and incorporate it into the simulations as well. So, first empirical result, we use a technique called local projections to run an event study, which is a kind of statistical model where you are interested in the effects of an event, like conflict incidents, on an outcome. And here, this x-axis is arranged as years since a civil conflict, so 0 is the year that the conflict occurs. And these point estimates and confidence intervals to the left of 0 or to the left of that red line are prior to the conflict. So kind of reassuringly, a conflict doesn't have an effect on growth prior to the conflict occurring. That's kind of a specification check. If we saw statistically significant estimates over here, it might suggest that there was something wrong with the model. And then what we do see in terms of after the conflict, or during the year of the conflict, is that there is a statistically significant decline in growth of about 1.5 percentage points during the year of conflict, and then nothing really else going on after. So the typical growth rate, or the average growth rate, annual growth rate, in this sample in years without conflict is about 1.3%. So this is basically, you can think of it as, on average, in the year with a conflict, there's no growth. There's no economic growth. It's total stagnation for 1 year, but then you kind of revert as long as there's no conflict in subsequent years. So it's a large effect. And then looking at how warming affects conflict risk. So this is based on our other paper. You see we get a pretty similar looking relationship. There's about a 10 percentage point increase in conflict risk in the poorest countries in our sample per additional degree of warming. The way that we estimate this, just high level, is we look for quasi-random perturbations in temperature. So we model the expected temperature basically, and we use those deviations that are as good as random to estimate the effect of a change in temperature on conflict risk. And we do that at different levels of income per capita, essentially. But then the richest countries, or even the richest, maybe like quartile of countries in the sample, have no additional conflict risk due to an additional degree of warming. So this kind of says that if growth occurred and all of this mass over here just moved over to the right, we would eventually estimate no statistically significant relationship between temperature shocks and civil conflict risk, or incidents rather. And then the last empirical piece is that warming slows growth. So here we do a couple things slightly differently from how they're done in my co-author's previous work. The most important thing we do differently is we drop years with conflict, because we know that conflict slows growth from our result 2 slides ago. And so we don't want to kind of double count that effect of conflict and the effect of warming when we go to simulate what happens with growth. So these effects are much smaller than in their previous paper, which probably has something to do with that. Part of the growth penalty of warming likely comes through conflict. But we still have, looking at where the mass of annual average temperatures is, most countries are on kind of this downward sloping portion of the curve where an additional degree of warming slows growth. So we take all of that and we put them together into simulations to try and understand something about how income per capita and conflict might evolve up to 2100 in the absence of any sort of intervention to alter those statistical relationships that we estimated earlier. So the way that we're going to do that is we use projections from the CMIP 6 And like I said, together with those estimated statistical relationships, we're going to use projections from 10 models to try and incorporate some climate uncertainty. Different models simulate different, or project different weather series out into the future, and so we want to capture some of that uncertainty in what will happen to temperature when we go to simulate. And then we're going to account for statistical uncertainty by sampling from the asymptotic distributions of those estimates. So for example, here, if you were at this temperature, you would be drawn from a normal that's kind of defined by both this point estimate here and this. This is a 95% confidence interval, but it would use the kind of related standard errors to define the normal distribution that would be sampled from. And then we're going to do 100 simulations for each of the 10 models, so we get 1,000 simulations in total. So aggregating everything together first, before getting into the specifics, here's the difference in projected log income per capita under no climate change on the left, and under RCP 7 on the right. RCP 7 is an increase in temperature of about 4 degrees Celsius by 2100. It's kind of like a baseline scenario in a way. It's kind of, again, fitting with this idea of if we don't do anything, what might happen. So just comparing the median levels between these, log income per capita of about 8 under no climate change in 2100 versus somewhere around maybe 7.7 or so 0.3 log points, somewhere greater than 30% reduction in income per capita in the average African country under these simulations. And you can see that there's a lot more dispersion under warming than not. That's partially due to basically sampling from the uncertainty of those parameter estimates. But you can see that there's a good number of simulations where average income per capita is lower than its level in 2023 in 2100, but really wide kind of distribution of outcomes. And then looking at conflict, so under no climate change, growth kind of pushes countries to the right on that downward sloping curve, and so we see a reduction in conflict incidence out to 2100, ending just under 30% of countries in conflict in 2100. Under RCP 7, we go up to just above 40%, so a 10 percentage point increase in share of countries in conflict out to 2100, and it's kind of a just monotonic increase, kind of like the trend that we've seen in previous decades. Zooming in on country level outcomes, there's pretty wide heterogeneity. Some countries like Botswana, Cabo Verde, Mozambique, they have high growth and low conflict in the no climate change scenario, and don't suffer a whole lot under the RCP 7. Slower growth, but no real increase in conflict. Mozambique is kind of interesting, same with Ethiopia, because they've had pretty intense conflict experiences even recently, but in the simulations they're both very fast growing historically, and so they get pushed to that part of the curve where there's less conflict. Then we have some examples like Senegal or Nigeria, where they have low but positive growth under the no warming scenario, and then get pushed into negative growth under RCP7, and also pretty substantial increases in conflict risk. A lot of countries kind of in this low-ish growth and low-ish conflict risk region see a similar kind of thing where they get pushed a lot down and to the right. And then we have some countries that kind of have persistent conflict in both scenarios and low growth, and again, don't see so much in terms of an effect of climate change per se, like Sudan or Niger. So those were country level averages. If we look at just the mass of country year simulations, we see that a lot of what's going on between our baseline no climate change scenario and RCP7 is a lot of countries in this no conflict and various levels of growth part of the distribution get pushed down into kind of this negative growth and higher levels of conflict part of the distribution, as well as maybe some movement over here from the high conflict countries. And then looking at the likelihood of negative growth between 2023 and 2100, there are some countries that kind of like persistently experience negative growth under these simulations, like the DRC. But there's a number of countries that where we see that between that climate change is basically pivotal in inducing this risk of negative growth, like Kenya, for example. Almost all of their risk of negative growth to 2100 is due to climate change in these simulations. Or another example, not as stark, but maybe a little over a third of Nigeria's risk of negative growth in these simulations is due to warming. One thing that we're interested in, because we've kind of motivated this with this kind of poverty trap style model, is how do the growth effects and the conflict effects interact? Is it that slow growth makes conflict more likely, which begets even slower growth, and kind of vice versa? And so what we're going to do is break down the effects in these simulations into three kind of subsets. Direct effects. So if we're looking at growth, that would be warming only affects growth through its effect on the growth rate. It doesn't affect the conflict risk, and so we can kind of isolate how warming affects growth itself. Indirect effects, that's going to swap it, so we're going to say warming only affects conflict risk, and then look at how that affects growth. And then feedback effects, where we're going to kind of allow for both of those channels to reinforce each other. So here's the growth decomposition ordered by declines in GDP per capita. And what you see for growth is that a lot of it is the direct effect of warming. It's kind of because there's a lot of warming in this scenario, 4 degrees Celsius by 2100, and the average effect of conflict incidence on growth is a 1.5 percentage point decline. There's just more scope for warming to reduce growth directly than via conflict. And so in total, we estimate that about 14% of the reduction in income per capita is due to these indirect and feedback effects through conflict. Most of it is via just the direct effect of warming on growth. We kind of see the opposite in conflict. A lot of the conflict effects that we see are due to these indirect and feedback effects, like through warming, slowing growth, keeping countries on the left-hand side of that downward sloping curve, and making conflict more likely under warming. I think here we get 82% of the increase in conflict incidence is due to these indirect and feedback effects. And then this is, so far, as I've kind of been emphasizing, this is we've been looking at things in the absence of any sort of intervention to change those statistical relationships that we estimated in the empirical section. So we wanted to say something about what if there was a kind of intervention that might weaken these effects. And so we simulated a kind of growth boost where countries get a 1 percentage point increase in annual growth in every year, basically. So it's intended to be, it's still a kind of large increase, but it's not an implausible increase in growth rates. And we're simulating a growth boost, so it's not so surprising that that there's a lot more income per capita throughout to 2100, even higher than in the no climate change scenario. So this completely offsets the effects of warming. But what I think is much more interesting is we see this kind of decline out to 2100 in conflict incidence, so ending at just above 20% of countries in conflict in 2100, as opposed to 40. So halving conflict incidence by 2100. So we don't know exactly or necessarily what kinds of interventions might generate that kind of a growth boost, but it's something to keep our eyes on, because these these effects of warming that we're simulating are disastrous. 200 additional country years of conflict by 2100, and an increased likelihood of continent average negative growth over 2023 to 2100, 12 percentage points. I kind of already highlighted these indirect and feedback effects. It seems like these matter a lot more for conflict than for growth, but still a pretty substantial share of the growth effect. And then, getting back to that growth boost simulation, in our handbook chapter, we also looked at kind of the evidence, the empirical evidence around mechanisms that reduce that, the effect of temperature shocks on civil conflict incidents. We found that what there's the best evidence for so far is that the social safety net is really important for weakening that. Places that have even an unconditional cash transfer or something like that have much weaker effects of temperature shocks on various forms of violence. And then political inclusion is another one where there's a good amount of empirical evidence. So including political minorities in decision-making processes especially high-level decision-making processes, also empirically has been shown to reduce the effects of those temperature shocks on conflict incidents. So these are policies that could potentially help us avoid some of those worse outcomes that we get in simulations. That's it. Thank you.
Thank you very much, Joel. Really appreciate the talk. We have some time for questions if there's something in the audience. I'll let you call me.
Yeah. Yes. Sorry, I saw you first. Yes.
Okay, thank you for presenting. I'm just wondering how you define conflict in this case.
Yeah, so we use, that's right here. We use this data set called the Uppsala Conflict Data Program / Peace Research Institute of Oslo Armed Conflict Data Set. The way that this is a country level data set measuring conflict events. They define conflict as it's more based around events. So if there are encounters between the state and a non-state, or it doesn't necessarily need to be a non-state actor, but the state and another actor that results in at least 25 battle deaths in a year, a calendar year, then that event gets recorded in the data set, and then we have incidents of civil conflict. So you only need one event in the data set in a year for us to call that incidents of civil conflict. So some of these are pretty low scale conflicts, which maybe is why the average effect is it's still very large, I think, the effect of conflict incidents on growth, but maybe not as devastating as you might think if you're thinking of kind of really large scale civil wars. Yeah.
Hi everyone, thank you for the opportunity. My name is Mama. I'm a GW student from Zimbabwe. I focus mainly on climate change, how it impacts women, girls, and other community groups. So I found this presentation interesting because where I come from, we are currently facing water shortages, droughts, and it's affecting women in other minority groups. And the other thing that we're facing, especially rural populations, they are facing what we call women and wildlife conflicts. In the sense that we have got national parks that are near rural areas. So these animals move from the parks and they start attacking people, looking for food, water, because the water is not sustaining everybody, including the animals. So I think this is an interesting study. It's bringing out some of the things that I know are happening in my community. So yeah, I would like to read more about it.
Yeah, thank you. This is actually, I know a little bit about human-wildlife conflict, but more so in the U.S. context than in other contexts. But that would be really interesting to look at, I think, to incorporate into some of this this kind of research agenda. Because you're right, I have heard kind of accounts of human-wildlife conflict, but never really thought about why does it necessarily occur. I think it would totally be interesting to look at how warming, like you're saying, kind of
for instance, it causes birds and animals to migrate from one place to another in search of food and other things. So they usually destroy crops, which can actually affect economic growth in the sense that our rural communities are agro-based. They focus mainly on agriculture. So when these animals migrate from one place to another, they affect crops, they destroy everything. So it actually leads these communities become more in poverty because they cannot have access to food and other things. The animals will destroy everything. And then the issue of water security also comes in because people need water for their agriculture and other things. So yeah, that's how we can actually study it.
Yeah, that would also be great in the sense that there's a mechanism already through the agricultural part. Thank you.
there is a causal relationship between climate and conflicts. So, and it mentions, so when the climate change 1 sigma, so the conflicts also increase.
Yes, so that was, this one?
Yeah, this one. So, my question is, whatever the sigma is positive or negative, so the conflict is also in an increasing way.
Yeah. So you're saying that it's kind of funny in a sense that like increases might lead to increased conflict, but also that decreases could lead to decreased conflict. Yeah, I think that that's more of a local phenomenon, just because kind of, you know, there's a lot of like geographic coverage in this literature, but a lot of it is from hotter countries, and then you kind of get something like this kind of effect, where, you know, if you're estimating it only in hotter countries, you're kind of getting this part of the curve. There is a little bit of evidence that in really cold countries you get this part of the curve, but there's just less empirical research from those contexts. Like one that stands out in my memory is that there's a paper on the effects of temperature on violent crime in Russia, and that is getting kind of like this part where you see that warming reduces conflict incidence, but it's kind of consistent with this U-shaped relationship rather than a linear one. It's just that a lot of the literature focuses on hotter places.
So you're using this period from 1960 to 2023, which has multiple sort of types of growth and also multiple types of popular conflict. And I'm thinking about, you know, Mozambique becomes independent in 75, right? So is the Civil War in there coded as conflict? That seems like a very different kind of thing than others. But I guess I'm worried that, like, if you go to your later charts, like some of the last things you showed us,
Some of the last things.
just to make you know, run forward and back. Yeah,
these
there.
ones.
So what we have is fairly flat growth to about 2000.
Right.
And then we have arguably a different growth regime. And so is this robust to changing the time period?
Yeah, that's a good question. We have not run this yet, but you know, it's kind of a natural thing to point out. Like, growth is just much quicker post 2000, and so the way that we run the simulations is that you get a baseline growth rate drawn from the country-specific empirical distribution of growth rates in years without conflict, but over the entire period. So anytime between 1960 and 2023, in a year where you don't have conflict, that could be your growth rate. So maybe it is more natural to restrict to years post 2000 or so, and use those because it looks like we've changed to a different kind of growth regime. That's something that we have thought about but haven't implemented yet, but should do it. And then as for the various kinds of conflict and do they get counted, yes, they do. So also, like, Sierra Leone's civil war is in there, and it has like a huge, you can just, it's one of those examples where you don't need the causal inference. You look at the time series and you see what happened to growth, but it's like, it's massive effect. So it's just, there are like instances of these like really, where is that one? There are these instances of really, really large conflicts that, or like wars really, that are in the data set, but the majority of conflict in Africa is like smaller scale stuff, and so when we go to estimate the average effect, it's, you know, smaller than what happened in Sierra Leone, for example. But it, you know, when we simulate, we're drawing from that entire distribution defined by that point estimate and standard error. And so you could have that 2 standard error kind of like tail outcome where you're losing 2.5 percentage points of growth, and rather than 1.5 or something.
We have another question online that I'll just sneak in here.
Sure.
Have you analyzed the effect of the degree of income inequality?
We haven't. That's an interesting question. We could, in principle, do it with the data that we used here, Marshall's disaggregated wealth predictions. That could be interesting to look at, because yeah, there's a lot of empirical evidence that inequality is a driver of conflict, even that inequality exacerbates the effects of weather shocks on conflict. And so I think that would be a natural thing to look at. But sorry, one addendum to that. In this country level data set, it's hard to do that just because the data aren't really there to look at income inequality over this really long time period.
In a lot of the graphs you were showing that talked about the effects on warming, on growth and conflict, the axes are labeled average temperature.
Mhm.
Are you looking at a change, like a warming in terms of pure, this country's average temperature was this and now it's this? Or are you using like the difference in temperature between different countries as like a proxy for warming?
This is, sorry, this is, so like this example here, like annual average temperature.
Yeah.
So what that's referring to is the average daily temperature within a year in a country. So like this histogram at the bottom is plotting that distribution. Empirically, the way that, or in terms of like the statistics, the way that we estimate this, yeah, this is right, okay, is, so we have these annual temperature averages, the averages over the daily temperatures within a country year. And then we're using country fixed effects together with year fixed effects, and then these country-specific quadratic year trends to isolate those kind of like random changes in annual average temperature within a country. So one way to think about, the kind of easiest way to think about this that I think broadly maps onto how this is working is like, think within a country, you fit a curve, like a quadratic basically, to their annual average temperature series. So, and then the deviations from that quadratic are the variation that's identifying this. Yeah, so it's most of the variation is going to come from within country comparisons.
Okay. Why are you using like warming instead of like rainfall? Is there climate change data? Because like in Africa there are lots of places there like rainfall driven, like agriculture things. So.
Mm-hmm. Yeah, totally. Definitely the majority of agriculture in Africa is rain-fed. Empirically, temperature matters more, both for these outcomes that we're looking at and for agriculture actually. So like, at least for things like maize, really widely cultivated staple crop, temperature is going to be the driving weather variable there in terms of variation in that productivity rather than rainfall. There is kind of an interaction between them, but it's I think like the high level answer is just that temperature is the weather variable that seems to matter the most for these outcomes. You can kind of see that, I think, in this meta-analysis figure. So these blue bars are for studies that use rainfall, and I guess it's hard to see from this figure, but we don't really get a statistically significant meta-analysis estimate of the effects of rainfall deviations on group conflict, but we get a strong statistically significant meta-analysis estimate for temperature. So it's just kind of what the data tell us.
Great, well,